Good morning, children. Today we are going to see the next subtopic in this chapter. Which chapter are we studying now? Human eye and the colorful world. Okay. So there are many doubts in our mind. How this is happening? How we have studied about rainbow. How rainbow is formed. There are many other questions. No, how rain is coming. And after studying water cycle, we came to know. Okay, this is how rain is formed. There are many doubts. We will get clear one by one. Okay. Now, atmospheric refraction. What do you mean by atmospheric refraction? This term itself tells that refraction which takes place in atmosphere is called atmospheric refraction. You are right. We have studied about reflection and refraction. We have studied that how reflection takes place. Light always travels in a straight line. We have studied. Then why refraction is happening? That also we have studied how refraction takes place when it moves from one medium to the other medium and why it is bending, what is the reason behind that, everything we have studied. We have also studied refraction which takes place in rectangular glass slab, and we have also studied in a triangular glass prism how refraction takes place. So there are many things, new concepts we are studying. Under that we are studying the next thing, that is atmospheric refraction. As I already said, that atmospheric refraction means the refraction which takes place in atmosphere is called as atmospheric refraction. But how? How is it happening? Atmosphere, we know that atmosphere is a blanket, right? And it is made up of gases. And will it be the same density? We know that it is different. No, the density varies. Okay, now atmospheric refraction means when you are moving from, see like this, if you are taking from up to down, you are standing here. This is one layer. Okay, we are taking it as one layer. This is the second layer. This is the third layer. This is the fourth layer. This is the fifth layer. Like that, full. It will be like this. Okay, atmosphere is like this, and we are taking one small portion to just find it out how it happens. And you are standing in this position, and we are focusing only on this portion. When light is moving, it's moving from rarer medium to denser medium. These two layers, if you take, this will act as a rarer medium and this will act as a denser medium. If you are taking next two layers, this will act like a rarer medium and this will act like a denser medium. These two layers, if you take, this will act like a rarer, denser. These two, if you take, this is rarer, this is denser. So from this you came to a conclusion that which layer is next to us? Denser. So the layer which is next to us is called as denser layer or denser medium. Optically denser, that's very important, that word. Optically denser medium, and above that it is rarer medium. If you go there and stand, the layer which is next to you is denser and the layer which is above that is rarer. So this is how it will be. Now you will see when sunlight enters through the atmosphere, okay, when sunlight moves through the atmosphere, it continuously goes from rarer medium to denser medium. That time what happens? Refraction takes place. So in one line, if you like to explain atmospheric refraction, what is this? The light which takes place, the refraction of light which takes place in the atmosphere is called as atmospheric refraction. This is very important. What is that? The refraction which takes place in the atmosphere is called as atmospheric refraction. But from which layer to which layer? It continuously moves from rarer medium to denser medium optically. Optically rarer medium to optically denser medium is called as atmospheric refraction. That is one definition. Now under this head we are going to see three examples. Okay. The first example is twinkling of stars. You have this doubt in your mind, no? Why the stars are twinkling? Mercury, Venus, Earth, Mars, Jupiter, Saturn, Venus, Neptune, Pluto. Pluto is a planet or not? It's not a planet, it's a dwarf planet, okay? So all the other planets, Mercury, starting from Mercury to which one? They are all not twinkling. Why they are not twinkling? Only stars are twinkling. The question is there in your mind. We will see the reason for that, okay? Do you know apparent position and actual position? See, if you are standing here, there are many layers above and star is at the top. From star, the light is coming down. When it is moving down, it should cross many layers. In the atmosphere there are many layers, and so it should cross everything and it should reach our eyes. So when it is coming like that, it will come from, first it will cross the rarer medium and then denser medium. Then rarer, then denser. Like that, when you are comparing with two layers, I said it is rarer. Otherwise it will be lesser, lesser, lesser. And the down layer will be denser. So when you are standing here and seeing, actually the star will be in one position. But when you are seeing, when it moves from rarer medium to denser medium, it will move towards the normal or it will move away from the normal. Yes, it moves towards the normal. When it is moving like that towards the normal, the position itself will change. So there are two positions, actual position and apparent position. Actually the star will be here, but when you are seeing, it looks like as though the star is here. This is apparent position. So actual position is different, apparent position is different. See here, there are many layers. Twinkling of star. How twinkling of star is taking place? The layer which is close to the surface, as I told you, it is optically denser. That is first point. The layer which is close to the surface of the earth is optically denser. We know that the atmosphere is not uniform. It is having different layers that to different density varies. So layers with different density. And it keeps changing. It is not constant. Okay, this density is there, it will remain like that for the next 18 hours. Not like that. It will keep changing density. So that is the second point. Here see, you are standing here and seeing. Actually the star is here. So actual position is here, but apparent position, you are seeing the star here. Okay, this is the actual position, but the apparent position is this. When you are seeing like this, when the light is moving from one medium, optically denser medium, rarer medium to denser medium, rarer medium to denser medium, like that it comes, you feel that twinkling. Actually star is not twinkling. When the light is moving from one layer to the other layer, you feel that the star is twinkling. So this is the reason. So if they ask this, you will write the definition like when sunlight enters Earth's atmosphere, it continuously goes from rarer medium to denser medium, and that is called as refraction. That means refraction of light which takes place in the atmosphere is called as atmospheric refraction. Three examples you can give. First one is twinkling of star. In case if they ask how twinkling of star happens, immediately you should give the first point. It is due to atmospheric refraction. Clear? It is due to atmospheric refraction. Then how it is happening? Atmospheric refraction, how it is happening? When the light is passing, the layer which is close to the surface of the earth is optically denser. Atmosphere, it is not uniform. It is having different layers with different densities. So the change is happening. Then you should draw this diagram. See one eye. Actual position of the star is here. This is apparent position. So when it is crossing different layers, you feel that the star is twinkling because of atmospheric refraction. So the light from the star bends towards the normal. We know that why the bending is happening, it is because the light is traveling from rarer medium to denser medium. So when it moves like that, we feel that the star is twinkling. That is the reason. One more question I wanted to ask you. Planets do not twinkle. Why? Will you be able to find out the reason for this? Planets are also near stars or away from the stars. Which one is nearest, planet or stars? This is a hint. If it is near, no twinkling will not be there. If it is far, no twinkling will be there. Then you find it out. Okay? So that is the first one. The second example what we are going to study is advanced sunrise and delayed sunset. Advanced sunrise and delayed sunset. How it is happening? Advanced sunrise. Actually, the sun is rising at 5:30. But you will see the sunlight at 5:28 itself. Actually, the sun is setting at 6 o'clock. But you will see the sunlight till 6:02. So that is advanced sunrise. Actual sunrise is 5:30, but you are seeing it at 5:28. So advanced 2 minutes. Okay. Delayed sunset. 6 o'clock the sun is setting, but you can see the sunlight till 6:02. So what is happening? Delayed sunset. What is the reason? Advanced sunrise and delayed sunset. We know that the sun is visible. See, sun is visible 2 minutes before the actual sunrise and 2 minutes late after sunset. Why it is happening? So it is the same. The reason is the actual and the apparent sunrise and sunset. No, the difference is 2 minutes. See here, this is Earth and this is atmosphere. We are standing on the Earth. No, we are on the Earth. So we are standing here and we are seeing this is the horizon. The line which is moving here, no, in the center, it is called as horizon. So the actual sunrise, see here it is. The sun when it is moving, no, actually it is here. But we will be able to see. See, the apparent position is coming here. So 2 minutes difference will be seen. Actually the sun is here, it has not reached here. But because of atmospheric refraction, you will be able to see the sun here 2 minutes before. Same way, during sunset also, the sun will be here. But you will feel as though it is 2 minutes delay. The sun will set at 6 o'clock, but you will see it till 6:02. So that is advanced sunrise and delayed sunset. So total we are getting 4 minutes additional daylight every day. Okay, 2 minutes during sunrise and 2 minutes during sunset. So daily 4 minutes we are getting extra. So this is the second example. Third one is sun appears oval. Have you observed, notice this? Sun appears oval. When it will be oval? During sunrise and sunset, if you see, it will be oval. But in the daytime, at noon, if you see, it will be circular in shape. Why this is happening? Okay. Sun appears oval at sunrise and sunset and it is circular at noon. What is the reason? Same reason. If they give these examples, no, you should write it is because of atmospheric refraction. In case if they ask for 5 mark question, you should write what is atmospheric refraction and you should explain all the 3 examples. Okay. During sunrise and sunset, the sun is near the horizon. See, if you are standing here and checking, it is near the horizon. Horizon is like this, it is near the horizon. The rays of the light which is coming from the upper and the lower edges are unequal. This term is very important. They are unequal. When the light is traveling, it is unequal. So, the sun appears which shape? Oval shape. But when it is just above the head, they do not bend. The rays are not bending and straight they are coming. So that is the reason we have studied, no? There is no refraction. So directly they are coming. So they are circular. Okay. But in the morning and in the evening, if you see, they will bend. So that is the reason you are able to get that refraction. Okay, so this is very clear. I think it's a very important concept. What is atmospheric refraction? The refraction which takes place in the atmosphere is called as atmospheric refraction and it is moving from rare medium to denser medium, the light which is traveling. And we have also seen 3 examples. First one is twinkling of stars. Actual position, apparent position. Advanced sunrise and delayed sunset, one example. Third one is the sun appears oval in the sunrise and sunset, but it will be circular during noon. Okay, so these are the 3 examples. Be very thorough with this concept. Tomorrow we will be seeing about scattering of light. Okay, bye.